Okay, so the topic that I will be discussing is the structure or phases of a compiler. Okay, as you see here, these are the structure and phases of the compiler. Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, machine code independent code optimizer, code generator, machine dependent code optimizer. So, lexical analysis. The lexical analyzer reads the stream of characters making up the source, program, and groups the character into meaningful sequence called lexemes. For each lexeme, the lexical analyzer produces as output a token of the form that is passes on to the subsequent phase syntax analysis and token. The first component token name is an abstract symbol that is used during syntax analysis, and the second component attribute value points to an entry in the symbol table for this token. For example, suppose a source program contains assignment statement position equals initial plus rate multiplied by 6. The character in this statement could be grouped into the following lexeme and mapped into the following token passed onto the syntax analyzer. 1. Position is a lexeme that would be mapped into a token, ID 1, where ID is an abstract symbol standing for identifier and 1 point to the symbol table for position. The symbol table entry for an identifier holds information about the identifier such as its name and type. Number 2. The assignment symbol equal is a lexeme that is mapped into a token. Since this token needs no attribute value, we have omitted the second component. We could use any abstract symbol such as a sign for the token name, but for notational convenience, we have chosen to use lexeme itself as the name of the abstract symbol. 3. Initial is a lexeme that is mapped onto token ID 2, where 2 points to symbol table 4. 4. Plus is a lexeme that is mapped into the token. 5. Rate is a lexeme that is mapped into the token ID 3, where 3 points to the symbol table for entry for rate. Star is a lexeme that is mapped into a token. 60 is a lexeme that is mapped into a token. Blank separating lexeme would be discarded by the lexical. Syntax analysis checks whether the token string meets grammatical specification of the language and generates the syntax tree. A syntax error is produced by compiler when the program does not meet the grammatical specification. For grammatical correct program, this space generates an internal representation that is easy to manipulate in later phases, typically a syntax tree, also called as a parse tree. A grammar of a programming language is typically described by context-free grammar, which also defines the structure of the. This tree shows the order in which the operation in the assignment. Position equals initial plus rate multiplied by 60 are to be performed. The tree has an interior node label star with ID 3 as its left child and the integer 60 as its right child. The node ID 3 represents the identifier rate. The node labeled star makes it explicit that we must first multiply the value of a rate by. The node label plus indicates that we must add the result of this multiplication to the value of initial. The root of the tree label equal indicates that we must store the results of the addition into the location for the identifier position. This ordering of operation is consistent with usual convention of arithmetic, which tells us that multiplication has higher precedence than addition, and hence the multiplication is to be performed before. Semantic analysis. Semantic analysis is applied by compiler to discover the meaning of a program by analyzing its parse tree or abstract syntax tree. A program without grammatical errors may not always be correct. Position is equals to initial plus rate multiplied by 60. What if position is a class while initial and rate are integers? This kind of errors cannot be found by the parser. Semantic analysis finds this type of error and ensures that the program has. Static semantic checks are performed at compile time. Type checking, every variable is declared before use, identifier are used in appropriate contexts. Check subroutine, call arguments, check labels. Dynamic semantic checks are performed at runtime, and the compile produce codes that perform these checks. Array subscript values are within bounds. Arithmetic errors, division by zero, pointers are not difference unless pointing to a valid object. A variable is used but hasn't been initialized. When a check fails at runtime, an exception. Intermediate code generation. In the process of translating a source program into a target code, a compiler may construct one or more intermediate representation, which can have a variety of form. Syntax trees are a form of intermediate representation. They are commonly used during syntax and semantic analysis. After syntax and semantic analysis of a source program, many compilers generate an explicit low-level or machine-like intermediate representation we can think of as a program from abstract machine. This intermediate representation should have two important properties. It should be easy to produce and should be easy to translate into target. We consider an intermediate form called the tree address code, which consists of the sequence of assembly-like instruction with 3 operands per instruction. Each operand can act like a register. The output of the intermediate code generator consists of 3 address code sequence. T is equals to int to float 60, T2 is equals to ID3 multiplied by T1, T3 is equals to ID2 plus T2, ID1 is equals to T3. Code optimization. The code generator takes as input an intermediate representation of the source program and maps it into the target language. If the target language is machine code, register, or memory locations are selected for each of the variables used by the program. Then, the intermediate instructions are translated into a sequence of machine instructions that perform the same task. A crucial aspect of code generation is the judicious assignment of register to hold. A simple intermediate code generation algorithm followed by code optimization is a reasonable way to generate good target code. The optimizer can deduce the conversion of 60 from integer to floating point can be done once and for all at the compile time. So into float operation can be eliminated by replacing the integer 60 by the floating point number 60.0. Moreover, T3 is used only once to transmit the value to ID1, so the optimizer can transform into a shorter sequence. So we have here T1 is equals to ID3 multiplied by 60.0, which is a float. ID1 is equals to ID2 plus T1. Code generation. The code generator takes as input an intermediate representation of the source program and maps it into the target language. If the target language is a machine code, registers or memory locations are selected for each variable used by the program. Then, the intermediate instructions are translated into a sequence of machine instructions that perform the same task. A crucial aspect of code generation is the judicious assignment of register to hold variables. Symbol table management. An essential function of compiler is to record the variable names used in source program and collect information about various attributes of each name. These attributes may provide information about the storage allocated for a name, its type, its scope, where in the program its value may be used. And in the case of procedure names, such things as the number and types of its argument, the method of passing each argument, for example, by value or by reference, and the type returned. The symbol table is a data structure and containing a record for each variable name, with this field for attribute of the name. The data structure should be designed to allow the compiler to find the record for each name quickly and to store or retrieve data that record. Grouping of paces into passes. The discussion of paces deals with the logical organization of a compiler. In an implementation, activities from several paces may be grouped together into a pass that reads an input file and writes an output file. For example, the front-end pace, lexical analysis, syntax analysis, semantic analysis, and intermediate code generation might be grouped together into one pass. Code optimization might be an optional pass. Then, there could be a back-end pass consisting of code generation for a particular target. Some compiler collections have been created or run carefully, designed intermediate representation that allows the front end for a particular language to interface with the back end for a certain target machine. With this collection, we can produce compilers for different source language for one target machine by combining different front ends with the back end for that target machine. Similarly, we can produce compilers for different target machines by combining front and back end. Compiler construction tools. The compiler writer, like any software developer, can profitably use modern software development environments containing tools such as language editors, debuggers, version managers, profilers, test harnesses, and so on. In addition to these general software development tools, other more specialized tools have been created to help implement various ways of compiler. These tools use specialized language for specifying and implementing specific components and use quite sophisticated algorithms. The most successful tools are those that hide the details of the generation algorithm and produce components that can be easily integrated into the remainder of the compiler. Some commonly used compiler construction tools. Okay, compiler construction tools. Okay, we have 1. Parser generator that automatically produces syntax analyzer from a grammatical description of a programming language. 2. Scanner generator that produces lexical analyzer from a regular expression description of token of a language. Number 3. Syntax directed translation engines that produce collection of routines for walking a parse tree and generating intermediate code. 4. Code generator generators that produce a code generator from a collection of rules for translating each operation of the intermediate language into machine language for a target machine. 5. Data flow analysis engine that facilitates the gathering of information about how values are transmitted from one part of the program to each part. Data flow analysis is a key part of code optimization. Number 6. Compiler construction toolkits that provides an integrated set of routines for constructing various phases of a compiler. Okay, so again, this is the basis of the compiler.